In this video, we're going to talk about something a lot of people get confused about. Can you use multiple charge controllers on the same battery bank? Now, there are actually a few real-world situations where this setup makes sense. First, maybe your system is already running, but now you want to expand and add more solar panels. Second, sometimes you get panels with different specifications, so instead of mixing everything on one controller, you separate them. And third, this is very common, your panels are installed in different directions. For example, some facing east, others facing south. So they get sunlight at different times of the day, and separating them improves performance. Now here's where most people get it wrong. A lot of us think that if you connect two charge controllers to the same battery, they need to communicate with each other. The logic sounds simple. If one controller is already charging the battery to around 13 volts, then the second controller might think, okay, battery is full, and stop working. But in reality, that's not how it works. Charge controllers don't just look at voltage and quit. They respond to the battery's actual condition, especially how it behaves under load and charge. Because of that, multiple charge controllers can actually work together on the same battery bank without needing direct communication. So how do you actually connect them? The setup is pretty simple. Each solar panel group goes to its own charge controller, and then both controllers are connected in parallel to the same battery. Let's say you already have a system with 4 panels connected in series to one controller. Now you want to add 4 more panels. Instead of replacing everything, you can just install a second charge controller and connect it to the same battery. This way, both controllers charge the battery at the same time. If you're using lead-acid batteries, there's one important thing to watch out for. These batteries often use something called an equalization cycle. This is when the voltage is increased by around 10%, occasionally, to reduce sulfation and keep the battery healthy. Now the problem is, if you have multiple charge controllers doing this at different times, it can overdo the process. And that's not good for the battery. So the safe approach is, only one charge controller should have equalization enabled. Now let's talk about something many people ignore: charging current limits, also known as C rate. If you push too much current into a battery, especially lead-acid, it can overheat and wear out faster. For lead-acid batteries, a safe limit is usually around 0.2 C. For lithium batteries, it can be higher, around 0.5 C to 1 C, depending on the battery. Let's take a simple example. If you have a 12-volt 100 amp-hour lead-acid battery, then 0.2 C means about 20 amps of charging current. That's a good match for the battery. Now here's where things can go wrong. If you add a second charge controller that also provides 20 amps, your total charging current becomes 40 amps. But your battery is still 100 amp-hour. That means you are now pushing double the recommended current, which can increase temperature and shorten battery life. Instead of stressing the battery, you should increase battery capacity. For example, add another 100 amp-hour battery in parallel. Now your system becomes 12-volt 200 amp-hour battery bank. And if we apply the same 0.2 C rule, 200 amp-hour times 0.2 equals 40 amps. Now your total charging current is perfectly safe again. One more thing. If the wires from each charge controller to the battery are slightly different in length, that's okay. One controller might stop a bit earlier than the other because of small resistance differences, but this is normal and not a problem. However, if you have multiple batteries in parallel, then proper wiring becomes important to ensure balanced current sharing. So to wrap it up, yes, you can use multiple charge controllers on one battery bank. They don't need to communicate with each other. Just make sure your total charging current stays within safe limits. Only one controller handles equalization, and your wiring is done correctly. Do it right, and this setup can actually make your solar system more flexible and efficient.